Hi, good morning. This is Lewis Whitcomb. This is the Department of Mechanical Engineering's online open house, November 20th, 2017. I see that we've got several viewers online. For this presentation, we've got two people here. Myself, I'm a former department chair of the Department of Mechanical Engineering. My areas of interest are robotics in extreme environments, in particular dynamics, navigation, and control of underwater robotics and space robotics. And with me here today is Gianna Valentino, a PhD student in the area of mechanics and materials, who is, I believe, beginning her fourth year of study in the PhD program. And her areas of interest are small-scale mechanical testing, MEMS in extreme environments, thin films, and nanotwin metals. And she'll be speaking a little bit later in the presentation. So a little outline of the presentation, which the whole thing should take half an hour or so. The goal of this presentation is to give prospective graduate students some information about mechanical engineering in general and our mechanical engineering program in particular. We'd like to say a little bit about our research and academic programs, about our faculty, some of the things that are unique about the Johns Hopkins University, and in particular, engineering at the Johns Hopkins University, and Gianna's going to discuss some of her experiences as a PhD student and what she studied before coming to Hopkins and what brought her here and what she's doing and what she might do afterwards. And we'll also discuss a little bit about what our graduates are doing out in the world today. So a little bit about Johns Hopkins University. We're one of the first true research universities in the country, founded in the 1870s. For the last almost 40 years, we've been the largest recipient of research funds in the United States, a significant step above the number two university, which is University of Michigan, Ann Arbor, an excellent program. And the university has 9 divisions. The Whiting School of Engineering is one of them. Applied Physics Laboratory is located halfway between here, Baltimore, and Washington, D.C. The Johns Hopkins School of Medicine is perhaps what we're known best for around the world. And we have #1 School of Medicine in the United States and #1 hospital in the United States. And there's several other schools, including the Krieger School of Arts and Sciences, the Bloomberg School of Public Health, and schools of education, international studies, and music. A little bit about our department. This is our photo of our department about a year ago, and I'm the guy just to the left of center wearing a baseball cap. This is a good many of our PhD students, most of our faculty, and a lot of our master's students. A little bit about the School of Engineering. The School of Engineering is located on the Homewood campus, which is north of the city center in Baltimore, and so it's not an urban campus with streets and streetlights going through the campus. It's actually a former plantation of 150 years ago, and it's got rolling hills, and it's a brick campus. It's very pretty. The Whiting School of Engineering shares this campus with the Krieger School of Arts and Sciences, so we have poets on campus and historians and physicists as well. The School of Engineering has 9 PhD programs, and of which mechanical engineering is one, and 14 master's programs, of which mechanical engineering is one. And we have 21 part-time master's programs, which are delivered primarily online, and our part-time program has worldwide reach. We have students from all over the world in every time zone. And the School of Engineering has about 1,600 graduate students, both master's and PhD, and about 1,800 undergraduate students, and about 2,500 part-time graduate students. So you notice that the ratio of usually in many programs, you'll have, for every 1 graduate student, you'll have 10 undergrads, and that's not the case here. We have traditionally been very focused on our graduate programs. We have excellent undergraduate programs as well. And in mechanical engineering, for example, the U.S. News and World Report for the last several years has ranked our program 13th in the nation, which is pretty extraordinary given our small size. Everybody above us on the list is substantially larger in terms of number of faculty and students. The School of Engineering has 181 full-time academic faculty and 31 research faculty, about just a little over 30 teaching faculty, and 43 research scientists who work primarily full-time on research. The mechanical engineering program is the oldest is one of the oldest engineering programs in the school. We were started just a little over 100 years ago in 1913, and we focus on research in areas including robotics, modeling and control, fluid mechanics, mechanics of material, mechanics in biology and medicine, and other things that we'll talk about. Right now, the mechanical engineering department has about 27 full-time faculty members, most of whom are tenure line. We have 4 teaching faculty in that group. We have about 110 PhD students and about 60 master's students. And right now, our undergraduate program is around 260, spread out over 4 years. So we like to say that our research is broadly focused in 4 broad areas, and I'll break that down a little bit in 2 slides into more detailed 7 different areas. But broadly speaking, mechanics in biology, medicine, fluid mechanics, and mechanics of materials are one of our oldest research areas, and robotics, control, and human-machine interaction are new and up-and-coming areas. And in fact, we in the Whiting School here have one of the leading robotics research programs in the world, and probably the leading medical robotics program in the world. So what I'd like to do is I'd like to switch and show you a little video about the graduate program in mechanical engineering.
Universities that are truly at the top of the chain tends to be known not only for their research, but also for other things such as the impact on the discipline. This is an institution that really sets the state of the art.
I make microfluidic devices that can be very useful for developing personalized medicine. I'm a tool developer, and that's the core that mechanical engineers can provide. We know how to design, how things move, how to make it more efficient.
Currently, we have funding from the Air Force to look at how to control flows over aircraft wings using computer simulation software. But we are able to take those same simulation tools and apply that to understand how blood clots form in the heart, how birds fly, how insects move about.
These are interesting materials that not a lot of people know how to characterize and model, and that's what we do, is we figure out how they work by developing new techniques to study the mechanics of the eye.
We're interested in trying to develop a more scientific fundamental understanding of what we call our human haptic perception or our human touch perception. If you're interested in the medical robotics field, I would say that Hopkins actually can't be beat.
I was really interested in coming to Hopkins because of its very large interdisciplinary action. Not only do you work inside the department, you work outside the department, and even far-reaching to companies and research institutions. When you work in industry, you have to be able to talk to the average person as well as the scientific person, which I don't think as a graduate student I really appreciated until I had to do both.
What sets us apart is our ability to apply these tools to a wide variety of problems, and also take advantage of the incredible opportunities for collaboration that exist in a place like Johns Hopkins. Any research project that you can think of and you're looking for a collaborator, there's a good chance that you'll find the world's expert in that topic right here in Hopkins.
Coming to Johns Hopkins has allowed me to kind of take my career in any direction, whether I want to work in academia, go to industry, or maybe a national lab. I have all of those opportunities, and I've been able to work with someone in every one of those disciplines to kind of get a feel for what I want to do.
My student will learn a lot of experimental skills, but in addition to that, they will interact with my collaborating doctors so that they understand the real problem that they have to tackle when they establish their career.
I work very closely with my students. We meet every week, and they'll get a lot of personal attention, a lot of guidance and mentorship. I usually know the ins and outs of their work in the beginning. Later on, they'll know much more than I will.
Very quickly, students become the leaders on these projects, the thought leaders on these projects. And that's the kind of environment that we try to foster here.
Johns Hopkins has set me up to be successful in terms of my career, academically, as well as in real-world experience.
I anticipate that there's going to be a lot of things happening here in the future, and I think it's being exciting to be a part of that.
That video was an experiment. That's the first video that we've produced on our graduate program, and the idea was to it's not a deep dive into each one of the research areas, but it just kind of gives you an overview of our faculty and our 4 broad areas. If you want to drill down deeper, I'd say that we really specialize in 7 different areas. And of course, on this list right here, I put robotics first because that's my area, robotics and system modeling and control. And so that's obviously the most important area for me. For Gianna, I think mechanics and materials and micro nanoscale science and engineering is the most important area. We have several faculty members who work in mechanical engineering and biology and medicine, and that's both at the molecular level, the cellular level, and the organismal level. So we have folks who are modeling and doing experiments with whole organisms, some who are doing modeling and experimentation with cells, and some who are doing it down at the reverse engineering mitochondria at the molecular level. We have several faculty members who work in the area of energy and the environment and fluid mechanics and heat transfer as well. So those are, broadly speaking, our research areas. If you go to our website, me.jhu.edu, you can drill down further, and you can, our research is broken down into 7 areas on that site, and you can drill down to see which faculty members practice and teach in the different areas. And you can look at some of the courses that we offer in these different areas, and you can then zoom over to the web pages for the different research groups in each of these 7 areas. So let me give you a brief overview of the 2 graduate degrees that we offer, an MSc in mechanical engineering and a PhD in mechanical engineering. And I'll start with the MSc. Our MSc students, of which we have approximately 60 enrolled at the present time, has 2 degree options. By default, when you enroll in the MSc program, you're enrolled as a non-thesis MSc student, and the degree requirements is that you need to take 10 courses, of which 6 need to be at the graduate level, and 2 of the courses have to be in applied math, numerical, or computational methods. The MSc is typically completed in 3 to 4 semesters, and it's generally considered to not be possible to finish the MSc 10 course requirements in 2 semesters. The other MSc thesis option that we have is for students to write a master's thesis, which is called a master's essay here at Johns Hopkins University. And the degree requirements there are that you need to take 8 courses and also complete a master's thesis that's approved by your that's both advised and approved by your master's thesis advisor faculty member. By default, when a student enrolls in the MSc program, we've just got 1 program, but there's 2 tracks within that program. By default, you'll be assigned an academic advisor from among our full-time faculty. If you are interested in doing a thesis research project, then the idea is that in your first term here, you'll shop yourself around, find an advisor who's willing to advise your thesis, and then normally you would switch to having that faculty member serve as both your academic and research advisor. And as I say, most of our master's students who are enrolling in Hopkins for the first time and got their previous degree at another institution complete the degree in 3 or 4 semesters. The other graduate degree that we offer is the PhD in mechanical engineering, and students enter the PhD in mechanical engineering typically with a bachelor's degree or a master's degree in an engineering or engineering related discipline, and that can be pretty broad. For example, we have students like Gianna who has her undergraduate degree in physics and then got interested in actually doing constructive engineering, and so pursued a graduate program in mechanical engineering. So our undergraduates, our PhD students come with, a lot of them come with a background in mechanical engineering, but a lot come with background in material science, electrical engineering, biomedical engineering, physics, and even math. The degree requirements for the PhD are that you need to, after 3 terms of study, you take an oral exam with mechanical engineering faculty members as the examiners, and the subject of the exam is typically mechanical engineering topics related to your intended research as a PhD student. And then after 5 terms of study, there's a graduate board oral exam, which is normally got 5 examiners, 2 of whom are from mechanical engineering and 3 of whom are from outside the department. And again, the examiners typically ask questions related to the area of a PhD student's research. And after that, the final requirements are that you finish your PhD dissertation and you present your thesis. And the presentation of your thesis is called a thesis defense. And it's presented both to the public and also to a committee of faculty members who approve your thesis, who read it, critique it, and approve it. And students usually take 4 to 6 years to complete the PhD, and the variation is due to differences in their experience coming into the program. So some of the students will already have an advanced degree, such as a master's degree, and other students will be matriculating in the PhD program directly from an undergraduate bachelor's degree program. So those are 2 graduate degrees, and students in our master's program, where do they go? A number go into industry or to government research labs, and both here and around the country. Our students really have their job-seeking opportunities are really global in scope, and not just local to the Baltimore, Washington area. And a number of our master's students go on to pursue PhDs, and those that do typically do so in the top programs around the country. The PhD graduates also go to sort of 3 different tracks. A lot of them become senior scientists at major research organizations in industry. Recent examples include students, former PhD students who are now senior scientists at Amazon Research, Google, Intel, Microsoft, Boeing, Lockheed Martin. It's a long list. And some of our students go into consulting with companies like Deloitte and McKinsey. And there's a big demand for, of course, our robotics students and other hot areas, such as our students who specialize in machine learning and things like that. Many of our students go on to positions in government labs where they run research programs and are thought leaders, and a surprising number of our students, really a sizable fraction of our graduate students, for our former PhD students, go on to faculty positions. And I can't list all the schools where our students are teaching as faculty, but it includes the best programs in countries around the world, including many UC schools, Vanderbilt, University of Pennsylvania, Harvard, Stanford, Carnegie Mellon, Johns Hopkins University, University of Massachusetts, Georgia Tech, the list goes on. So I'd like to, at this point, reintroduce Gianna Valentino, a PhD student in mechanical engineering. You saw her on the video, and she's here to tell you a little bit about her experience at Hopkins.
I'm Gianna. I am in my 4th year at Johns Hopkins University in the PhD program, and I wanted to talk about how I got started here at Johns Hopkins and then kind of what I've been working on since I got here. So my career at Johns Hopkins really started in my senior year as an undergraduate student. As Professor Whitcomb said, I have a bachelor's in physics from St. Joseph's University in Philadelphia, and I applied to Johns Hopkins in the fall of my senior year. So what really led me to make the switch from physics to mechanical engineering had to do with my research as an undergrad. When I was an undergraduate, I did research in small-scale microfluidic devices coupled with optics. And doing some literature review on that, I became very interested in MEMS, which stands for micro-electromechanical systems. So you have moving parts electrically and mechanically on the same platform. And that really gave me the idea to go to engineering in general, and I thought that mechanical would be the best fit for my needs. So I applied to a wide variety of schools, but when I came to Johns Hopkins to interview, I met up with my current PI, Professor Kevin Hemker, who actually had a project for creating new materials for MEMS devices in more extreme environments. So higher temperatures, longer life cycles, which really perfectly fit my needs as a graduate student and what I wanted to work on going forward. So what I work on now is to create these new materials for MEMS devices at high temperatures and longer life cycles. And currently most MEMS devices are made out of silicon, but we are actually trying to pioneer metal MEMS, so use metal instead of a semiconductor for MEMS applications. So I do a whole variety of things, very interdepartment. I take probably half mechanical engineering, half material science courses, and I really get to blend the two of those together. The biggest thing for our project is that we get really, really high strength. So the strength of our material is, double, triple that of current material, so polysilicon. And the big benefit is it's filled with these nanotwins. And that's kind of what's shown here on the right a little bit. So if you compare the material that we're working with, that's a metal alloy of nickel, molybdenum, and tungsten, so that's the red curve, you'll see that we just have much more strength and a lot of linear elastic behaviors compared to the traditional nanotwinned materials or polysilicon. So really what I've been working on is how I can characterize these in terms of mechanical testing, thermal testing, really try to understand why we get this behavior. And if I can understand why, then we can integrate these materials into future MEMS devices. So that's what most of my graduate research has been on. And going forward, I'm going to try to synthesize this with companies and other collaborators that we've had across the US in terms of universities and industries. And it's been a great experience here thus far. So that's just a little bit of an idea of what I work on. But I want to talk about Baltimore in general. So Baltimore is a really great location. It's only 1 hour from DC, so it's super accessible, especially with the MARC train. So that is right from the train station here in Baltimore, which is right close to campus. There is a Hopkins shuttle that goes through the Hopkins schools. So the Whiting School of Engineering is on Homewood campus. It goes all the way to the medical school. And in between, it stops at the train station. So it's really accessible to get to the train station to go to DC. Or New York's only 3 hours from here as well. And the really cheap options would be to take a bus. The Bolt bus or the Mega bus can actually only be $1 if you get it far enough in advance. So there's a lot of places you can go around here. But my favorite thing about Baltimore is all the food. So there's so many different kinds of food to try here in Baltimore, different cultures. And that's actually what my friends and I do most of the time, is try different restaurants from different regions and just see how we like the food and how it compares. But the other large benefit to Baltimore is all of the art. So pictured here is the Baltimore Museum of Art, which is actually on the back of Homewood campus, and it's free, so it's great. If you're on campus, you can pop over, go inside, as well as throughout the city, there's also other art museums as well. And then the surrounding areas around campus, this is not all of Baltimore, of course, this is just the immediate areas. So Homewood campus is in Charles Village, so that's super affordable and walkable to campus. So those that don't have cars, you definitely want to live in Charles Village. You can just pop over to campus every day and come back. That's a really convenient place to live. A decent amount of graduate students live around campus just because it's so accessible. And then Remington is right off of campus as well, and they just opened up a new marketplace, so a big food place. It's a really fun time to go with your lab mates, with friends in general, and just try a bunch of different restaurants in one large area. And then Hamden is the other really popular area that is very unique. Every place has its own feel. There's a bunch of different restaurants and little shops and bars. So you can go out and try new things. There's always an event going on the weekend. There's always something to do around the area. And I personally live in Mount Vernon, which is a little bit south of campus, and the shuttle comes right to where I live. But there's also two dominant areas that students tend to go out in, which is Fells Point and Federal Hill. Those are also very easily accessible. Everything I've talked about is within 5 miles of campus, so it's really accessible to get to, whether it's the bus or you take an Uber or something like that.
We're at the question and answer session of the presentation. The first question is, I wanted to know just how competitive the MS is in mechanical engineering with a specialization in materials. I'd say that the admissions to the MS in mechanical engineering in all of our areas have similar standards. They're fairly high. GPA, if you consider a 4.0 scale, the GPA of our successful candidates are typically above 3.4 or 3.5, with a GRE of 158 or higher, and a GRE quantitative of 158 or higher, a verbal of 148, and for students whose first language is not English, a TOEFL of above 100 is very important. And we typically offer admission to around 50% of our applicants. We get a very strong, very excellent applicant pool, and we offer admission to about 50%. Got a question. I've completed my master's in materials and bachelor's in mechanical and want to pursue a PhD in mechanical engineering. How competitive is it? I'd say that our PhD program is considerably more competitive than the master's program. Students typically come in with a GPA above 3.4 or 3.5 on a scale of 4. with a GRE quantitative above 160, verbal a GRE above 150, and a TOEFL well above 100. And I'd say that in our master's program, about 50% of the students are offered admission, and in the PhD program, it varies from year to year, but approximately 20 to 30% of applicants are offered admission. Next question is, what type of financial aid or scholarships are available? For the MSc program, there is no financial aid available, and students are responsible for covering their tuition and also providing for their living expenses. And in some cases, faculty are able to provide some financial support for health insurance premiums to master's students, but that's rare. A PhD program is different. PhD program students have full coverage for their tuition, their matriculation fee, health insurance, and they receive a stipend of around $30,000 a year. And many of our first-year PhD students were able to offer departmental fellowships that cover their stipend and tuition for the first 9 months. And then after that, a PhD student is normally supported by their PhD advisor, or in some cases, students have NSF fellowships or DoD fellowships. So a number of our students are highly competitive, and so they compete for these national fellowship awards successfully. How competitive is graduate funding? Is it possible to get a TA or RA during the MSc? Let's see. As I said, we don't normally offer we're not able to offer financial aid to MSc students, and so students are responsible for their tuition and living expenses. And we do not have full-time RA or TA positions that provide full tuition and stipend coverage. Instead, students in our department who serve as TAs, either conducting problem sessions or review sessions or grading homework assignments, we compensate them essentially by the hour. We estimate how many hours they'll be serving for their various responsibilities each semester, and then pay them essentially an hourly rate for that. So there are some other graduate programs where there's the possibility of working about 20 hours a week for full-time support that includes stipend and tuition, and that's not how our program works. So so it's not possible to fully support yourself as a TA-ship or RA-ship in our program. The costs of an MSc, a student asked about the cost of studying for Masters in Mechanical Engineering. For the 2017-2018 academic year, which we're in right now, tuition was $52,170. Health insurance, Hopkins health insurance, which is required if you're not covered separately under health insurance, is about $1,400. And we estimate minimum living expenses to support you for a year you need to have at least $20,000. One student asked, they're I believe interested in the PhD program, and they asked whether it's required to have publications already in order to be a successful applicant to the PhD program. No, we don't expect our students to have published before matriculating in the PhD program. Although if you have, it certainly is a mark of distinction if you're publishing in a good venue. The question is about design. So a student says, I'm interested in design, particularly with regards to mechanics and medicine. How do students typically interact with the design process? Well, many of our students who are interested in design will take courses in multiple departments, such as our computer and integrated surgery 1 and 2, if they're interested in medical devices and medical device programming in software. And we've just created a new course this year in human-machine interaction. Professor Jeremy Brown is teaching that. It's on haptics and proprioception, and that will be offered every year. We have a upper-level undergraduate course called Robot Sensors and Actuators, which is taught every year, and also an upper-level design course called Mechatronics, which is taught every year. And many of our master's students take those courses, particularly if they haven't had a lot of previous experience in the laboratory and working with real hardware. And next question was, who on staff needs new graduate assistants next fall? So we have a very research active faculty, and in fact, this question came up in a recent faculty meeting, and I think that almost all of the full tenure line faculty are going to be looking for new PhD students in this next cycle. And our PhD program is highly competitive, and we draw students both from around the world, and some of the top students in our master's program will be encouraged to apply to the PhD program. Next question is, from looking at our website, it seemed the question reads, it looks like control systems are the control systems research here are mostly on medical in nature. Are the non-medical control systems heavily worked on? Well, I can answer this one because control systems is my area of research. And I've been here at Hopkins. I was one of two people who helped create the robotics program and controls program within mechanical engineering back in the mid-90s, and I've been here over 20 years. While I have worked in the medical robotics area, research area a bit during that time, most of my control systems research has been non-medically related. So primarily I've been looking at dynamics, navigation, and control of underwater vehicles, underwater robotic vehicles for oceanographic applications, and also been looking at problems in systems and control in space telerobotics. So the idea of using a telerobotic satellite to via remote control perform servicing on a satellite while it's on orbit under the remote control from a human operator that's on the ground. Other faculty members in mechanical engineering who work on controls not medically related include Marin Kabilarov, who works on planning and control in both aerial, terrestrial, and marine systems, and Noah Cowan, who reverse engineers living organisms. So he tries to figure out how creatures in nature use their sensory and control systems to navigate in the world and to sense their environment, both optically, acoustically, and using electrosense. So there are fish that sense their environment with electrical fields. And another person who works in control systems is Jeremy Brown, who works in the area of haptics and human-machine interaction, and he's interested in understanding how humans sense and interact with the world, the actual physical interaction with the world, and that's really I would call it in part a control systems problem, because you're trying to identify the inputs and outputs of the system and its response. Next question is, how does it work for a prospective PhD student to find a thesis research advisor? Well, for our PhD students, our PhD students are admitted with an assigned PhD advisor. In some cases, there's multiple assigned PhD advisors, and the student will do a rotation through different research groups in their first year before settling on a particular research advisor. I'd say that the thing that one should do is, I should back up a bit. In graduate PhD programs, there's generally two ways programs admit students. In some programs, students are admitted as a pool with no designated advisor, and they're expected to do rotations in different research groups, and by the end of their first 9 months or 12 months, they'll have agreed to work with an advisor, and an advisor will agree to work with them. And so I'll call that the pooled admissions process. Typically, very, very large programs do that. And our program is small to medium in size and very intensively cultivated. And so we don't do the pool admission process. So students who are admitted are assigned a research advisor, and in some cases, they're assigned to multiple research advisors, and they'll do a rotation amongst students in the areas that they've expressed interest in. So a good thing to do, a good thing for an applicant to do, is to specifically indicate which areas one is interested in doing research, and which potential advisors one is interested in potentially working with. And also, it's a good idea during and preceding the applications process to reach out to faculty members who are of interest to you and If you live nearby, then make a campus visit and meet with some of the research groups and the faculty and graduate students. If you don't live by, then schedule a meeting via phone or Google Hangout with the faculty member so that you can get to know them better. Make sure you've done your homework and you've read their papers. Don't reach out to them and say, "Hey, I haven't read any papers of yours. Tell me what you do." So it is a good idea to reach out to potential research advisors before and during the application process. Do you have lab rotations when students can decide on their final advisor? Most of our students are admitted to with a specific named advisor. Sometimes there's more than one, in which case there will be some kind of a lab rotation process. And while your assigned advisor normally ends up being your PhD advisor, it is possible, and students sometimes do change if it turns out that their interests upon matriculation have been different than what they thought they were pre-matriculation. Thanks everybody for dialing in. So this is our first web information session, and Gianna was able to join me here. Hey, Gianna.
Yeah, thanks to anyone that was listening. If you have any questions, obviously you want to talk to Mike Bernard. He is awesome. He can answer all of your questions about applications, as well as I think my email is on here. If anyone has any questions, they can email me as well.
Yep. And so my email is on there. It's on your screen right now. And sitting across from me is Mike Bernard, our academic program manager, who knows everything there is to know about the ins and outs of our academic program. You're welcome to contact any of us. I hope to speak with many of you in person. Thank you for attending.